Hi class, this is Neil and this is lesson 10 on inverse functions. Alright, in today's do now, we're asked to determine the domain and range of the function graph below, and we're going to state our answers in both inequality notation and interval notation, or state them in both, basically. Alright, so first of all, let's kind of determine, or let's remind ourselves what domain and range are. Remember, domain is all x that are included in the function and in the interval that's described, and the range is all the y values. Okay, so first let's kind of determine what are the bounds of this function. So what are the smallest and largest x values, and what are the smallest and largest y values? Okay, so let's look here. Oh, don't want to give it away. All right, I'm going to draw, for the domain, I'm going to draw a vertical line. Cut it out here. And now the leftmost bound, again, this is the domain, and that occurs here. Now, domain, remember, is x. Now, because I see a filled-in circle there, I know that the lowest value is at -4, and I can say -4 is less than or equal to x. The largest value occurs here. Okay, so for my largest value then, that occurs at 7. That occurs at 7, and notice, you might not be able to see it now, but notice that the circle is not filled in. So I'm going to write less than 7. X is less than 7. Okay, for the range then, remember, range is the y values. The smallest y value occurs at the lowest y point, the minimum point of that function, which is here. Okay, and that's at -5. And now one thing we would want to ask ourselves is that circle filled in? And it is. So I'm going to write -5 is less than, is less than or equal to y. And now the maximum point, or the largest point, occurs here. Okay, and that is at 8. And because, again, that circle is filled in, I'll write less than or equal to. Okay, so we've done that in inequality notation. So now we need to do it in interval notation. Okay, so domain first. Now notice this -4 is included. So I'm going to do a hard bracket there at -4, but the upper limit, 7, is not included. So I'm going to do an open parenthesis there. Or I guess that's a closed parenthesis. All right, next we have our range. And now notice, for my range, both the lower limit and the upper limit are included. So our range extends from -5 to 8. And both of those bounds take brackets. All right, so let's take a look at this introduction to inverse functions as a way to kind of understand what it is they do. All right, so in Roman times, the Emperor Julius Caesar could send messages to his army by encrypting phrases using a type of encryption that has since become known as the Caesar cipher. This is actually true. An example of the Caesar cipher is in action is shown below. Okay, so we have this sentence, math is awesome, and Caesar is doing something to that sentence to produce this kind of jibber jabber. So he's doing something to the letters in that sentence to create this new gibberish sentence. So it says the encryption function takes plain text as an input. So it takes math is awesome, or each letter there, as an input, and outputs an encrypted text. It says figure out and describe how the encryption function works. Well, one thing we might want to do is take a look at each individual letter. So our input is M here, and our output is O. Let's look at another one. Okay, our input is A, and our output is C. Well, it might help us if we write out the alphabet, if you haven't seen it already. All right, so if I start with A. Oh, sorry, let's not use A. Let's use that first letter, M. So if I started at M, something happens to N to get me to O. Well, it looks like I'm going down 2 letters. Let's see if that also works for A. So if I start with A here, my output is C. So I've moved down, again, 2 letters. So it seems that the cipher is output is 2 letters after the input. You might say it's input plus 2. Let's say plus 2 letters. All right, so if we were to encrypt each of these then, Batman. So if I start with B, I go down 2 letters, I would have D. If I start with A, I go down 2 letters, I'd be at C. If I start at T and go 2 letters, V. M, we already know, outputs an O. A outputs a C. And N outputs a P. Okay, what about secret? Okay, so for secret, if I start at S and I go down 2 letters, I'd be at U. E gives me a G. C gives me a E. R gives me a T. E again gives me another G. And T gives me a V. Okay, so here we have described that an inverse function of encryption is decryption. So basically it undoes the encryption. See if you can decrypt each of the following phrases using the inverse of the Caesar cipher. Okay, let's see if I can see my alphabet again. We can. Okay, so it undoes it. So it takes, this is now an output, and it turns it back into an input. So that means if I were to start at C, or I ended up something encrypted at C, to decrypt, I go back 2 letters. So I would go to A. So at T, I would go back 2 letters to R. At G, I would go back 2 letters to E. Okay, so for the next one, T, I go back 2 letters. We already know that's R. Q, I go back 2 letters to O. D takes me back to B. And then we see Q again, which is O. V takes me back to T. And U takes me back to S. Okay, for the last one, JWOCP. So J takes me back to H. W takes me back to, I'm not sure, I can just draw a little arrow for myself, to U. O takes me back to M. C to A. P to N. So our robot's human. So here we're told that the encryption function and decryption function are inverse functions. Okay, in general, what do you think it means for one function to be the inverse of another? Well, one way we can think about it is that the inverse undoes the other function. One way we can also think about that is that the inverse takes the output takes us from the output back to the input of the original function. All right, so let's take a look at one of these in maybe like a Regent style question or sort of what we'll look at in Algebra 2. So we're told let f of x equal 2x minus 8. Determine the inverse of this function f, and we see this kind of crazy looking thing, f negative 1x, like what does that even mean? It means what we read this as is f inverse x, f inverse of x. That's all that negative 1 means. Okay, so now there's actually a procedure we're going to follow here to find that inverse. The first thing we're going to do is replace f of x with y. So I know f of x is the same as y. So I'm going to rewrite my function here as y equals 2x minus 8. Actually, let me do that in same color so we can kind of see the steps. So y equals 2x minus 8. All right, so the next thing I'm going to do here is I'm going to switch x and y. So I'm going to switch where my variables are. So instead of y equals 2x minus 8, I'm going to write x equals 2y minus 8. Okay, the next thing I'm going to do here is I'm going to solve this equation for y. All right, so to do that, I need to get y by itself. So to get y by itself here, I'm going to start by adding 8 to both sides. Cancels here. This will give me x plus 8 equals 2y. To get y by itself, I'm going to need to divide both sides by 2. This cancels, and I'll have, let's just come up here, y equals x plus 8 over 2. All right, the final step, purple, is I am going to now replace y with my special function notation for inverse, f inverse x. So now I'm going to write f inverse x equals x plus 8 divided by 2. Now, a special note, this is absolutely 100% correct, but what I can do, and what's sometimes done, is we can actually split this numerator, or this kind of fraction, into two separate pieces. But what I mean by that, I can write this as x divided by 2 plus, now what's 8 divided by 2? It's 4. Let me actually write it out so you can kind of see how I got 4. So 8 divided by 2. So all I did is I split it into two separate fractions, which of course simplifies to x over 2 plus 4. You might also see it written as 1/2 x plus 4. Okay, so all of these, this one, and this one, well, all of them, in fact, are equivalent. If you just get to here, though, you're on the right track. All right, so for the important stuff, we're going to follow the same procedure that you saw above. So f of x equals 3x plus 2. I'll start by replacing f of x with y. My next step is to switch the variables. Okay, once I switch the variables, I solve for y. So I get x minus 2 equals 3y. And now solving for y, I would divide by 3. So I end up with y equals x minus 2 divided by 3. My final step is to write f inverse x equals x minus 2 divided by 3. Do I see that answer? And I do. Choice 2. Okay, for the next one, same thing. So replace f of x with y. Switch the x and the y variables. So that's kind of what I did here. Next, I'm going to solve this equation for y. So x plus 12 equals 6y. Divide both sides by 6. And I'll get y equals x plus 12 divided by 6. Last step, write f inverse x equals x plus 12 divided by 6. Do I see that? No, I don't. Ugh, oh no. All right, let's see what we can do to maybe manipulate it. Now, the first thing I might do to manipulate my answer so I get something that I see is I'm going to split that into two fractions. I'm going to write x over 6 plus 12 over 6. Okay, I still don't see that. So I'm going to write x over 6, simplifying that as plus 2. I still don't see that. So I'm actually going to rewrite this as 1 over 6x plus 2. And that is choice 3. All right, see you guys in class on Monday.